wanted to give some helps to making sure you know the difference between converge or diverge with a sequence, and then we're moving into this new converge or diverge with a sum. And so if a sum, infinite sum, or series converges, that means it can add up. And if a sum diverges, that means it cannot be added up. And back over here in sequence land, a sequence converges if, as we go to infinity, the terms are approaching one specific limit. And then if we get a DNE or an infinity as a limit, then the sequence diverges. So in general, we take a limit, right? This is what we do with these. We take a limit. Take a limit as n goes to infinity of whatever's in here, right? Okay, so in taking the limit, there are some tools. So tools you get to use. You could just be doing limits with infinity. You could take highest powers. Or your limit could entail like an infinity over infinity where you have to do L'Hopital's. And so that's when you have to change it to x's, right? You could encounter a problem where you get to use squeeze theorem. And then there's this R limit theorem that I presented, where if you're taking the limit of a number to the nth power, right? Some number to the nth power, and n's are going to infinity. So if that number is less, the absolute value it is less than 1, then you get 0. And if that number, absolute value of r, is bigger than 1, then you get infinity. Okay, so these are all just limit tools. There's one unique rule, and that's the alternating sequence rule, and that's when you have a changing sign. So -1 to the n or -1 to the n plus 1, however it is. So the rule is you take the limit of the nth term only. You never put the -1 in there. And if this equals 0, then you can say the whole thing converges to 0. If you take the limit of this nth term and it doesn't equal 0, it could even equal a friendly number like 1. But that means it's alternating between 1 and -1 forever, so that's when it diverges. Okay, and what this one is, it's nice to say ASR on these because this is a unique rule, right? So the sequences have one rule and the rest of it is just taking a limit. Okay, so if this says converge or diverge, so, and if it says if convergent, find the sum, then you have two options. You would have a geometric sum, or you're going to have a telescoping sum. And pretty soon we're not even going to have those words find the sum. If it's geometric, what you're looking for is some number to the nth power. And that's where you're going to write out the terms, a plus ar squared, just plugging in whatever it starts with. Oftentimes it's 1, sometimes it's 0, but you can identify the a and then find out what the r is, right, by seeing what you multiply a by. And if the absolute value of r is less than 1, it converges, and the sum is a over 1 minus r. Okay, so that's something you all need to know. If the absolute value of r is bigger than 1, then it diverges, so it doesn't add up. Okay, a telescoping sum is going to look like polynomial-ish. And so you can see the difference, nth power polynomial, and this has many steps. I'm not going to go through them all, but the first step is to do partial fraction decomposition. So that's finding the sum. Okay, so if it doesn't say find the sum, let me just come down here, and we still have this, there's different things we could do. So we have tests in this series. In this series, we have tests. So we could do the p-test, and I'm not going to write down what it is. You just need to know it. It could do the integral test. An integral test is most useful if you have an e to the n or an ln of n inside your sum, right? You could end up saying, oh, it's a geometric sum, and you don't have to find what it adds up to. You can just say converge or diverge. You've got basic comparison test. And many times the geometric or the p-test comes up while you're doing basic comparison test, or you've got the test for divergence, So be careful with this test for divergence, because remember, you're checking to see if it diverges, right? So you're never going to say converge by test for divergence. So I give the analogy, you go to the doctor, you take a strep throat test. The test comes back, you have strep throat, you don't have strep throat, but it doesn't tell you that you've got pneumonia. So this is a test to see if you've got strep throat. If it diverges, you get it diverges, or you don't know. You could have pneumonia, you could have something else. So if you find yourself, you look at a sum, and you start to take a limit of that nth term, because you're so ingrained. That's what you do up here with sequences. If you start to take a limit, remind yourself, oh, wait a second, if I'm taking a limit of that nth term, I'm doing test for divergence. And if I get 0, it means nothing. I need to keep going and do some other test, right? So keep going. Getting a limit of 0 means absolutely nothing. Well, I hope that helps.